I will just go quickly over the few points I made in to summarize day one, in case you weren't there at the end of the day. So we thought day one went very well. The staff was very helpful, very few technical glitches, and presentations were all great. So we heard on three general topics related to synthetic motions. There were several talks related to that identified the issue of frequency content, varying in different studies, up to 16 hertz in some cases. High frequency content is clearly difficult to produce. Higher resolution crust models are needed. Computational effort can really go very high, and that's the reason of using high performance computing if we go to these higher frequencies. It's possible to produce realistic pulse periods for near fault motions. We have seen some results about that. Using artificial neural network seem promising to complete the missing frequencies. There were a few talks about one-to-one comparisons with recorded motions, which in some places these are rare, like the talks in related to Grenoble. There's not much real records there, but still there were some good comparisons. It's possible to capture PGAs, PGVs, response spectra, in a good way. Still, high frequencies are a challenge, but that's what some of the things we should focus on. Synthetic motions generated for small, medium, and large earthquakes, including aftershocks, are possible. Duration is still a challenge. It needs improvement with more information related to geological layers. There were several other things, but these are like the highlights related to synthetic motions. Geotechnical modeling received um, good attention related to soil structure interaction, availability of some new tools in the soil quake net, which can be used with synthetic motions. Also, some tools that are available either in OpenSeas or as an add-on to other existing commercial codes like Abacus and others. Modeling of near surface layers, the importance of soft soil as was evident in previous earthquakes in Mexico or obviously Loma Prieta, that these lessons were reiterated. Necessity of handling a nonlinear soil response, uh, usually collecting information from representative areas, as collecting soil information from large areas could be a challenge, but it is something we need to pay attention to. In the last set of presentations related to structure regional scale simulations, we heard about rupture to rafter, or going from the rupture all the way to the structure elements. EQSIM was presented, and how it's going to reshape our future research is something exciting, and we all looking forward to that. Simulation from earthquake to rupture to structure response in 3D. It seems that's the next big thing that may motivate us to continue all the good work we started in the past. Um, Coupling ground motion simulation with exposure and fragility to estimate seismic risk at CT scale is a consequence of doing this rupture to rafter or the work of EQSIM. Simulated motions applied to highway bridges was also introduced in some presentations with different types of validation uh, showing promising results. Still some room for improvement there. Simulated motions to model and simulate seismic landslides was also pointed out in some talks, and some very important talks related to social science simulations, including traffic, economic, or recovery simulations after earthquakes. Very impressive work that was shown using also high performance computing, which require things like scalable solvers and algorithms, platform for optimization, and supercomputers for ground motion simulation. And finally, regional scale simulation for multi-hazards, things like fire following earthquakes were pointed out. All very important research directions with promising results, with that show the need of making use these new computational powers that keep growing in a rapid way. So that was quickly the summary of day one. I am looking forward to day two, which, as David said last night, it will be different. And I turn it on to David to tell us how different today will be from yesterday.